So before we can start TLC, we need to have spotters in order to properly spot our TLC plate. Pulling a TLC spotter requires a propane torch and just a plain glass pipette. So we turn our propane torch on and we heat the center of the pipette until it gets nice and flexible. Once we're there, we can pull it apart. And this thin glass that you may or may not be able to see is what we use to spot our TLC plate with. And we can very easily break that apart into pieces that are easily usable. Now, to do TLC, we need a thin layer chromatography plate, which looks like this. These are plastic back. They can be cut with scissors or a paper cutter. And they have silica gel, which is our polar stationary phase on one side. That side will look slightly more dull. And the other side is the plastic backing, which is much shinier. Everything you do with TLC should happen on the dull side, the side with the silica gel. Now, before you start to get set up for TLC, you always want to make sure that your plate is clean and it doesn't have anything on it from touching it or any other way. And so you can see when I shine the UV light on it, we see all green on the plate. And that's what we're looking for. These TLC plates have a green fluorescent indicator that when UV light hits them, it fluoresces green. Now I'm going to draw in my baseline. I'm going to do that only in pencil. Now, if we do that in ink, then the ink will also separate when we develop the plate. I've now got two solutions set up, and I'm going to spot them. So these are my spotters that we pulled. And we don't need a lot. But the nice thing is, if we keep this under the UV light, we can actually see that we got enough because the spot turns dark. I've now got a second compound here that we will spot next to it. All right, so now we're ready to develop the plate. I'll just zoom in better so that you can hopefully see those dots. We're going to set up our developing chamber. We're going to pour a small amount of solvent in there. That amount of solvent should not come up to our baseline. In addition to that, in order to saturate our environment better, we're going to place a piece of filter paper in the back, and then we can place our TLC plate in to develop. Finally, we're going to stick a watch glass on top. That watch glass being on top is important because otherwise we will see the solvent evaporate from the top of the plate before it reaches its conclusion, and that will mess up our results. So it's going to take a few minutes, and so we'll let that come up to the top and then come back and look at the results. So if we take a look at our progress, you can see that we are about 2/3 of the way up the plate. So if we want to get to within about 1 centimeter of the top, so we're almost done, but we'll just give this another minute or two. And now for the purposes of this recording, we're going to say that that's close enough. So I'm going to take the plate out. Should always do that with tweezers, which I'm not finding at the moment. So let's do it that way. Before I do anything though, I'm going to draw a line for where the solvent went to. Finally, what I should see, once we've given this a moment to dry, I want to let all the solvent evaporate from the plate, is we should see our spots, and they should have moved. Again, probably not terribly easy to see here, so I will circle them just in case. But we have on the left our compound moved to right here, and our dark spot here on the right. Always circle the compounds with pencil. That way you can draw a picture of what these plates look like in your lab notebook. When you measure the RF values, what you're going to be recording your distance that your solvent traveled is the distance from the baseline up to where we marked at the top, and then the distance that the spot traveled is from the center of the spot down to the baseline. For this spot, center of the spot down to the baseline.